Video we will see what is the need of array, what is array, types of array, how arrays can be declared, how arrays can be initialized, and how data is to be represented in memory, or you can say the memory representation of an array. Fine. See, I guess you are aware with the fundamental data types, that is int, float, char, double, etc. And if I write like this, int a is equal to 5. It means you have declared one variable name is a, the data type of this variable is int, and the value stored in this variable is 5. Fine, this is one variable declaration you can say. Now how this value is to be stored in memory, let us check. So let us take, this is our main memory, you can draw it vertically also. Fine. So see, these are bytes. So you can say memory is a long tape of bytes, you can say. Byte means 8 bits. This is 1 byte, this is 1 byte, this is 1 byte, like this. So this can be extended to this side and this side also. That is why I am taking open-ended. So now how this variable can be stored here, when the compiler compile this line, then what happens? What memory manager will do, memory manager will allocate some space for this variable to store this value 5 here. How much space would be allocated? See, the data type int, how many bytes it will take? 4 bytes. In typical compilers, to store an integer data type, it will take 4 bytes. In traditional compilers, we consider it 2 bytes. So you can say 2 or 4, it's up to you. Generally we take 4 bytes. That is why I am taking, for storing one integer it will take 4 bytes. Fine. So we have only one integer, that is why how much memory would be allocated? 4 bytes would be allocated. 4 bytes. Fine. It means how many bits? 8 into 4, that is 32 bits, because one byte is equal to 8 bits. Fine. Now how this data is to be stored? First of all, this decimal number 5 is to be converted into binary number, sorry. That is in 32 bits. How in 32 bits this number can be represented like this? 29 zeros would be there, and then we will write 101. Now this binary number is to be stored in memory. Now how this data is to be stored? This 4 bytes is to be allocated 1, 2, 3, 4. Let us suppose these 4 bytes are to be allocated to store this 5, like this, these 4 bytes. So these 4 bytes are, this is a closer look. Here we are going to store these digits like this, and 101 at the end. 8 bits here, 8 bits, 8 bits, 8 bits, that is 32 bits. This is how the number is going to be stored in memory. Fine. And suppose at address, you can say, see, address is always in hexadecimal form. But here for simplicity purpose I am taking, let us suppose the address of this byte is 100. Let us suppose. So address of this byte would be 101, 102 and 103. So it's 100, 101, 102, 103. These 4 bytes to be used to store this integer. See, this address would be in hexadecimal form always. It's not like 100 or 1000 or something like this. Hexadecimal means always hexadecimal would be represented by prefix with the 0x, then you can say 677 or C and 0, something like this. In this form the address would be there, but here I am taking just 100 for simplicity purpose. So now we will discuss what is need of array. See, in this variable we can store only one value at a time. If I want to store 6, then what would happen? I will write here 6 and 5 is overwritten. 5 is no more now. Fine. If I want to store 7, then I will write 7, and now 5 and 6 are no more, and here you will insert 7, or you can say overwritten those 5 and 6. So at one time you can store only one value. If I want to store more than one value, suppose in my class I have 60 students and I want to store roll numbers of all the 60 students. Now what would happen? You have to take, in this case if you follow this approach, in that case you will have to take 60 variables, because one variable can only store one value at a time. See, because we have to process large amount of data, that is why the concept of array came. Now you will modify this declaration such that under one variable name we can store roll numbers of all 60 students. That is what array. Now how you can do this? See, same data type would be there. Here we have name, but rather than storing one value, now I want to store 60 values. Now obviously you have to tell the compiler that I want to store 60 values. Then you have to give the size of your array. So here like this we are going to give the size. Fine. So this is what you can say the declaration of array. General syntax would be what? Data type, then array name is A, then in brackets size of the array, and here you will write what? Constant value. Okay, see, this is invalid declaration. If you write int A, this is invalid declaration, you cannot leave it blank. This is also invalid declaration. If you write int A and here you write size is n, sorry, int n, and here you write n, this is also invalid declaration. Here you have to write what? Constant. You can write here a variable, but in that case, for that case you have to declare macros. Before main function and below that header files, you will declare one macro. You can say hash define variable name n, size is 100. In that case, after that in main function you can write int A, and in brackets you can write that variable name. Fine, that is different logic. But simply you cannot declare something like this. You have to declare this data type, then array name, then size. Size should be constant. Now see, this declaration of array is language specific. I am here considering the syntax in C language. In Python maybe it's different. In Pascal, in you can say that Fortran language, the declaration syntax would be a little bit different. So it is language specific. Fine. Now this is what the array declaration. Now see, this is declaration of 1D array. Types of array. Types of array, 3 types of arrays are there. 1D array, one dimensional, 2 dimensional, and multi-dimensional array. So in this video I am going to talk about 1D array. So this is declaration of 1D array. So in this we are having one row with 60 columns, 60 values in columns. Fine. Now see how the arrays can be initialized, and after that we will discuss how the arrays can be represented in memory. So see how you can define an array. What is definition of array? You can say that array is a collection of more than one data items or more than one elements, but condition is what? The data type of those elements should be same, or you can say collection of the more than one data items of same data type. See here 5, we can store 5 elements in the array, but all the 5 elements should be of integer type. Let us take this example. See, this is a valid array because here the size of array is 1, 2, 3, 4, 5. 5 elements are there, but all the 5 elements are of same data type, that is integer. Here all the data items are of same data type, that is character. You can also declare a character array like this. Data type should be character. Suppose name of array is A or B, you can take, and size is suppose 10. That is also fine. You can take float array also like this. Float array name is suppose B and I am taking size is 5. So that is also fine. But see, this is fine, this is fine, because all in this array all the elements are character type, same type. But this is not valid. This is not valid because in this array 1, 2, 3, 4, 5 size is 5. But here we have integer value also and character value also. So different data types items are there. That is not possible in array. All the data items should be of same data type. Now how the elements of the arrays are stored in this memory? All the elements are stored in consecutive locations, or you can say continuous locations, one after another. How the data is to be stored in the memory I will discuss in this video only, but that is very important point. Fine. Okay, all the elements are stored in consecutive locations, and index would be started from 0, although somewhere we can start the index from 1, that is also fine, but generally we take the index of array should be started from 0. Now how to access those elements of the array, we will also discuss that thing. Fine. See now how the array is to be initialized. Arrays can be initialized by 2 types. One is at compile time and one is at run time. Compile time means static initialization would be there, At the time of declaration only, you will specify what elements you want in the array. And at runtime means while executing the program, at the runtime you can ask from the user what are the elements of the array. Fine. Now one more important point about array is that it is a fixed size array. Now we have declared size of array, that is 5. Now at runtime you cannot change the size of the array. It's not like you can store 6 elements. Fine, you can store only 5 elements maximum. You can store 2 elements, that is fine, but you cannot exceed from this limit. This is fixed now. This is, maybe you can say, a drawback of array, that you cannot change the size of the array during runtime. Although one concept is there, that is of dynamic array, but we will discuss those things in later. What is dynamic array, what is a linked list, something like this. In this video I am discussing only the fundamentals of array. So now we will see how array can be initialized at compile time. First of all, see, at the time of declaration only you will specify the elements of the array. Suppose 5 elements I want, so I can specify here these 5 elements. Fine, so that is fixed. These 5 elements would be stored in the array. This is compile time initialization. Here the size is 5, so you cannot write here 6 elements. If you write 6, 7 or more than 5 elements, then it will give a compile time error. You cannot exceed from this limit. Although you can specify less than 5 elements. If I specify here only 6 and 2, that is also fine. Remaining 4 position, it will store what? 0. It will initialized with 0. But more than 5 you cannot write here. So this is compile time initialization. Now how these elements is to be stored in this memory? Let us check. See, now the size is to be allocated is 5 into 4, that is 20 bytes. Memory manager will allocate 20 bytes, but in consecutive bytes should be allocated. Let us suppose he will allocate from this address, and let us suppose address I am taking 100. So till 100 to 109 here the data is, the memory is to be allocated to these elements. Now how the data is to be stored? First of all, the 6 is to be converted into binary form, and then the data is to be stored here. 6 is to be stored here, 6 in these 4 bytes, next 2 would be stored. So this is how this data is to be stored. See, first of all, this is to be converted into binary form. Fine, but I am not taking here binary form, I am just simply writing 6 in these 4 bytes, 2, then 4, then 3 and 0. See, these 6, 2, 4, 3 and 0, these are in consecutive locations, continuous locations. So for simplicity purpose, I am going to represent this data like this. Fine, this block is having these 4 bits, this is also having 4 bytes, this is also having 4 bytes, that is 32 bits. But for simplicity purpose I am writing here like this. So this is our array, name is A, and address of this is 100. So now address of this 2, this address of 2 would be what? See, this 2 would be 104, this would be 108, this would be 112, and this would be 116. And why so? Because this element is going to take 4 bytes, 100, 101, 102 and 103, that is why it is 104. How this address is to be calculated? What is the formula? So the formula is, before going to formula, let us check this index would be 0, 1, 2, 3, 4. We are going to start the index of this array with 0 for simplicity purpose. Somewhere it is also started with 1, that is fine, but here I am going to start with 0. So now how the data is to be accessed, how you can calculate this address? So this is how you can write. At a of 0, at index 0 we have 6, a of 1 we have 2, a of 2 we have 4, something like this. Fine. How to access the data, how to calculate the address? See, we know the base address of the array. Base address means from where the array is to be started. Array is to be started from 100, so base address is 100. So how does this address is to be calculated? Suppose I would be started from 0 till 4, means 0 to n minus 1. or you can say size of array. N is equal to size of array, right? So if you want to access I is equal to 2, this data, when I is equal to 2 means I is equal to 2, that is third value. How to access this value? So the formula would be base address plus this I value into size of data type you have taken. The data type of array is here int, so size would be 4 bytes. Now how to calculate address for this location I is equal to 2? See, base address is 100. So these address would be in hexadecimal form. Just to make you understand, I am taking here integer form. 100 plus I value is 2. You want to calculate address for this 2 into size of data type. Data type is int, size would be 4 bytes. So now here you will take 100 plus 8, that is 108. The location would be 108 where this value is there. The data is to be there. So that is why A of 2 is what? 4. This is how you can, after finding the address, you can access the data. Fine. So see, the array follows the random access. You can access any data with a constant time if you know the base address, because if you know the base address, you just simply need to do only 1 plus and 1 into 1, you can say addition, and 1 multiplication, and you can access the data. So the time taken for this accessing is order of 1, that is constant time, and array follows what? Random access method. And let us suppose if you take character array, here we have char and array name is B, and I am taking here size is 10, and here I am initializing this character array also, and I am taking some values. Fine. So now how these value is to be stored? See, I have taken size is 10. So in memory, how many bytes is to be allocated? So for this, size of character will take 1 byte. 1 into size is 10. Here we have 10 characters. So 10 bytes would be allocated. Fine. Somewhere 10 bytes should be consecutive. Let us suppose this array is also there, and after maybe not 119, but from 122, 10 bytes till 132 has been allocated to this character array B. So how the data is to be stored here? Here the space is to be allocated. Now this data is to be stored here, but here we have null, because we have specified only 1, 2, 3, 4, 5 characters, but the size has been allocated to for 10 characters. So this is, now you can say that wastage of space. So now see, the drawback, you can say another drawback of this array is what? You have to specify the size at compile time, but in advance we don't know how much space we needed. Maybe sometimes you have declared that I want an array of size 100. So now that 100, the space of that 100 elements, or you can say 400 bytes has been allocated to you for this array name A, but actually you are storing only 10 integers. So you are wasting that space, na? So that is a drawback of that array, that static declaration of array. And sometimes you want to store more data than you have declared here. Now suppose you have declared the size of array is 100 for 100 integers, but now actually when run time you want to store 200 integers, but that is impossible because you have already declared the size. Now if you ask to the memory manager that I want to store 200 integers, so I want to extend my array. So now what memory manager will do? Memory manager will allocate you a space of fresh new space of for 200 integers, so you can say 800 bytes in consecutive locations. And what memory manager will do? Memory manager will copy the data, because previously he has allocated space for 100 integers to you, so those 100 integers would be copied from there to the new location. Fine. So that would be very tedious work to do. So this is how you can initialize the array at compile time only. Now at run time, how to initialize? So at run time you can initialize the array using loops, maybe for loop, while loop, do while loop, and some predefined functions, standard functions, that is scanf. I'm going to write down that code here. See, let us suppose I have declared an array of size 5. Fine. Now at runtime I want to ask from the user which data he wants in this array. So now what I'll do, see, printf function is for what? For printing something on the screen. So I am writing here, enter the elements of array. So this line is to be printed on your screen. Now for taking the input from the user, you will write what? Scanf. But first, the most important point about this is you have to use some loops, because you are going to take continuously 5 integers from the user. So we'll suppose I am taking for loop here, and I would be started, index would be started from 0, I less than size minus 1, that is 4, and I plus plus. So within this for loop you can write %d and array name a. So this is how during runtime you can take that value from the array. I am going to discuss it, how the data is to be taken from the user, how the data is to be stored in the array in next video. So these are some points that we have discussed in this video. See, array is a fixed size. Fixed size means once you have declared the size at compile time, you cannot change it at runtime. Fixed size sequenced collection of data items of same data type. Data items should be of same data type. That is also a drawback of the array. Fine. To access a particular element in the array, what you will have to write? Just write array name, and in the brackets you will write the index value. Suppose you want to access the first element, then you will write what? Array, and in bracket you will write a 0, because we are going to start the index from 0. Data items are stored in continuous locations, and random access is there. You can access any element, and that will take a constant time, order of n. How you are going to access that I have discussed with the help of formula. Types of array are 3: 1D, 2D and multidimensional array. We have discussed how 1D array, say this topic we have discussed, declaration, initialization, accessing of this 1D array. In next video we are going to discuss how the data is to be inserted, how the array is to be traversed, different types of operations on 1D array first of all with their time taken, and after that we will discuss what is 2D array as well as how the data is to be accessed from 2D array. Fine. So I'll see you in the next video. Till then, bye bye. Take care.